Hi everyone. In this video, we are going to go over ester reactions. So we'll talk about how to make esters and then also the reactions that esters can perform. So just as a reminder, the ester functional group has an ester linkage between the carbonyl carbon and the oxygen atom here. And remember that this is similar to a carboxylic acid, except we have a carbon group on the end instead of a hydrogen. So one way that we could make an ester is through what's called esterification, kind of a fancy word for making an ester. So this is the process of forming an ester linkage between a carboxylic acid and an alcohol. So down below, we've got our carboxylic acid on the left, and this R group could be any alkyl group. It could be methyl, ethyl, it could be a benzene ring, really anything that is a hydrocarbon can go there. And then we've also got our alcohol, OR with an H attached, and this could also be phenol. And remember, phenol is a benzene ring with an OH group attached. So if we add some acid, that's going to help the reaction occur. It's going to act like a catalyst. And we'll also add some heat just to add enough energy for the reaction to occur. And what happens is the OH group from the carboxylic acid is going to team up with the hydrogen from the alcohol, and that's going to create a water molecule. Then what's left over, so let's see, from our carboxylic acid, we have our carbonyl group attached to the alkyl group that's left. From our alcohol, we have that OR group. So those are going to team up together to create our ester. So again, we're forming this ester linkage between the two. So we're kind of creating a new bond there. Okay, so this is one way to make an ester. And notice that we have equilibrium arrows here. So this reaction could go backwards and forwards depending on the conditions of the reaction. So for example, if we were to cool down the reaction or add more water, then we could reverse the reaction and go back to the carboxylic acid and the alcohol. And sometimes we don't really want that to happen. But first, let's look at some examples in real life that we could perform. So for example, if we combine butanoic acid, so there's 4 carbons in the chain, and then we've got our carboxylic acid on the end. If we combine that with ethanol or ethyl alcohol, again, we'll form a water molecule. And then the other 2 components that are left over, those are going to team up. Oh, whoops. I meant to draw that to the oxygen, not the carbon. There we go. Those are going to team up, and they're going to create something called ethyl butanoate. So ethyl butanoate is actually strawberry flavoring. So remember before I talked about how esters can be used as flavoring agents in food. You can also add them to perfumes and lotions to give them nice smells. So this one in particular tastes like strawberries. Now in another reaction, if we were to combine salicylic acid, which you'll notice has a carboxylic acid group on a benzene ring, and then we have an OH group on the neighboring carbon. If we combine that with methyl alcohol or methanol, we end up with something called methyl salicylate, and that's also known as oil of wintergreen. So wintergreen gum, toothpaste, really anything that has that wintergreen scent or flavoring, it contains methyl salicylate. So esters are pretty cool in that way, in that they are so fragrant and they do have, sometimes they have good flavors as well. Although I know some people really hate wintergreen, so. Okay. Now, earlier I mentioned that esterification has those equilibrium arrows, so we could go back towards reactants. But sometimes we don't want that to occur. We just want to make our product without any risk of going back to the reactants. So in order to remove that possibility, we can use something other than a carboxylic acid to create our ester. So instead of the carboxylic acid, we could use something called an acid chloride or an acid anhydride. Now you could put carboxylic in front because these are derivatives of a carboxylic acid, or they're derived from carboxylic acids. So for example, here instead of the OH group on the end, we have a chlorine. For the carboxylic acid anhydride, instead of a hydrogen, we have this other carbonyl group with an alkyl group attached. And what's great about using these two instead of a carboxylic acid is we obtain higher yields of the ester that we're interested in. So let's look at the general reactions here. So again, we're going to use an alcohol in each reaction. But instead of a carboxylic acid, we're going to use either an acid chloride or an acid anhydride. So in the reaction on the top, we're going to again see the carbonyl carbon bond with the oxygen from the alcohol to create our ester linkage. And that's going to create our ester. But instead of producing a water molecule as a byproduct, we're now going to create hydrochloric acid as our byproduct, HCl. Now, if we use an acid anhydride, something similar occurs. The carbonyl carbon is going to team up with the oxygen from the alcohol. And then the other portion of the anhydride is going to team up with hydrogen to create a carboxylic acid. Now, this can become problematic because in this second reaction, we have two very distinct products, and we're going to end up with a mixture of an ester and a carboxylic acid. Whereas in the first reaction, we have an ester and hydrochloric acid, which we could potentially remove. So it just kind of depends on what you have available and how easy it is to separate your products from each other. But either way, notice that we just have a single arrow. We've gotten rid of those equilibrium arrows. So there's no risk of going back to the reactants. We're just going forward to the products. So we get higher yields for these two reactions. And these are things that chemists have to think about a lot of the time. For instance, this becomes really important in the pharmaceutical industry. You want really high yields of your drug that you're making. So oftentimes chemists have to come up with high yielding reactions. All right, so let's practice making esters. So I'm going to give you 3 different reactions, and I want you to figure out the products for each. So let's start with esterification. So again, that involves a carboxylic acid and an alcohol. And then we also use an acid and heat to get that going. In the second reaction, we're going to use an acid chloride and an alcohol. We'll just use the same alcohol. And in the last reaction, we're going to use an acid anhydride and that same alcohol, methanol. So see if you can figure out the products for each of these three reactions. So you can pause the video, and when you're done, you can unpause and we'll go over them together. Okay, let's start with the first one. So again, in these reactions, these esterification reactions, the OH group from the carboxylic acid is going to team up with the hydrogen from the alcohol. And then we're going to form an ester linkage between the carbonyl carbon and the oxygen on the alcohol. So this will give us an ester. And water. And I'll just put a box around that just so we keep it separate from our other reactions. Now, what would we name that ester? What's the name of that ester? So we again remember start by naming the group that's bonded to the oxygen. So that's methyl. And then we need to name the other part of the molecule based on how it would have been named when it was the carboxylic acid. So let's look at our original carboxylic acid. What's the name of that? Methanoic acid. Or no, sorry, ethanoic. Getting my prefixes mixed up. There we go. Ethanoic acid. We've got 2 carbons there. So remember what we do is we drop the ic acid and add ATE. So then it becomes ethanoate. So this is methyl ethanoate. All right, let's look at our second reaction. We've got an acid chloride and an alcohol. So this time, instead of a water molecule, we're forming hydrochloric acid. And then the other components will team up together. So let's see, we actually end up forming the same ester, methyl ethanoate. But this time our byproduct is hydrochloric acid. Okay, and then what about our last reaction? This time we have an acid anhydride and an alcohol, the same alcohol that we've been using, methanol. So this time, this entire second half of the molecule, the acid anhydride, is going to team up with the hydrogen from the alcohol. And then the other 2 components that are left over are going to team up together and create a bond. So let's see, we're going to again end up with the same ester at the end, methyl ethanoate, but this time our byproduct is a carboxylic acid. All right, and we actually form ethanoic acid. So the original carboxylic acid that we saw before. Okay, so 3 different ways that we could make the same exact ester, but we end up with different byproducts and different yields. So the last two reactions will give us higher yields because there's no risk of going back to the reactants. But the first reaction, if we just remove that water as it forms, so maybe if we boil it off, that might help us isolate methyl ethanoate a little more easily. So, these are just things to think about. Okay, so let's talk about the reverse of esterification, because we mentioned before there were equilibrium arrows, so that means we could go backwards or forwards. Now, if we go backwards, that's called ester hydrolysis. So this is just the reverse of esterification. So we start with our ester, add water and catalytic acid. So again, that just helps the reaction along. And we end up with our original carboxylic acid and alcohol, or phenol. So actually, enzyme catalyzed hydrolysis of esters in animal fats and vegetable oils is a really important process that takes place when fats and oils are digested by the human body and other biological organisms. So this is a reaction that occurs in our bodies quite regularly, especially when we consume animal fats and vegetable oils. So let's look at some specific examples of ester hydrolysis. So let's say we're starting with ethyl acetate. Okay, also called ethyl ethanoate. So what's going to happen is the alcohol component on this end is going to grab onto the hydrogen from water, and then the carbonyl group here is going to grab onto the OH from water. So then we end up with our carboxylic acid, which in this case is acetic acid, and the alcohol, which is ethanol or ethyl alcohol. Down below, we have a slightly different carboxylic acid, and again, the OR group is going to team up with one of the hydrogens from water, and the rest is going to team up with OH. So then that's going to give us our original carboxylic acid here and the alcohol. There is one other reaction that esters can perform. It's called saponification. This is actually how we would make soap. So saponification is similar to hydrolysis, but it's carried out with a really strong base to produce a carboxylic acid salt. So in this reaction, we start with an ester, and then we react it with a strong base like sodium hydroxide. And what happens is the hydroxide, the hydroxide is going to pair up with the alkyl group on the oxygen in the ester to create the alcohol. And then the shared electrons between oxygen and the alkyl group will be left behind to create a negative charge on oxygen. So sodium, which is positively charged, will team up with that negatively charged oxygen. So we get a carboxylic acid salt like we saw in the last video. So an example of this, if we have something called methyl benzoate, again, that OH group is going to team up with the methyl part of methyl benzoate. So that gives us methyl alcohol. And the other components that are left over team up to create our ionic compound or salt called sodium benzoate. So all that being said, I know I just threw a lot of reactions at you. Let's kind of review all the reactions we've talked about with carboxylic acids and esters. So let's start with our carboxylic acid. In the last video, we saw that if we react this with water, carboxylic acids will react as a weak acid. Water will act as a base. So let me just write that. This is our base. And we end up with dissociation. So we would get our H3O plus. And then our ionic compound at the end. If we react the carboxylic acid with a strong base like potassium hydroxide or sodium hydroxide, we get a carboxylate salt and water. If we react that carboxylic acid with an alcohol, that's where we get our ester. So that's esterification. Once we have an ester, we can react that with water and acid, which would act as a catalyst, to give us a carboxylic acid and an alcohol. And then if we react the ester with a strong base like potassium hydroxide or sodium hydroxide, we get a carboxylate salt and an alcohol. And then we also saw that to create an ester, you could use an acid chloride plus an alcohol to give you an ester, or an acid anhydride plus an alcohol to give you an ester and a carboxylic acid. All right, so that wraps up carboxylic acids and esters. Next time, we're going to focus on amine reactions and amide reactions, and that should be the end of the chapter. All right, so I will see you then.